Hello.
Hi, good afternoon, all.
Hello.
Afternoon.
Good afternoon.
Hello.
Hello.
How are you, Dr. Barbosa?
I'm doing well, thank you. How are you?
I'm good.
Good. Let's see, we're up to 45 here. I've got a few other people coming in.
Did you used to work in radio?
No, I did not. Why is that?
It just sounds like you kind of got like a radio voice. Maybe it's
Radio
just
voice. Well, I spent a career in the Air Force in aviation, so that may have something to do with it. Talk a lot on the radio.
Yeah, well, that makes sense.
Let's see. I want to make sure I only let people in that should be in here. Okay.
These programming exercises are fun.
Which ones?
All of them.
You're talking like the projects?
Yeah.
Good stuff. That's what I like to hear.
It's like a puzzle.
That's how I see it. It's time pressure always makes something not fun, or can make something not fun, right? Yeah, it's interesting overcoming the challenge.
I tried to
Twice
view
every
project 2.
What about project 2? I just posted it, so I'll talk about that today. What did you say about it?
I was trying to look at it to see what it was about, but it was
Yeah.
still hidden.
It should be up. I
It's
think
up
it's
now.
up. Mm-hmm.
Yeah, I'm looking at it right now.
Yeah, I just posted it a couple of hours ago, or maybe it was a little over an hour ago. Mm-hmm. All right, I think I've got 56 of you. There are some folks missing here, but we'll pick them up as they come in, since we've got quite a bit to cover. All right, let me turn on my camera here. Didn't realize that was off. All right, so today I hope to get through some slides. Slides are sort of a double-edged sword. They give you information, but a lot of people don't like them. They feel that instructors are hiding behind slides, and that's not my intent. There's just a lot of information, and so I will try to cover the slides more quickly so that I can give you an example of a piece of code that is in multiple files, and in essence is closely related to project 2. Okay, closely related in the sense of the things that I'm asking you to do. Okay, so I'm hoping to spend roughly the 50 minutes or so going over the class stuff, highlighting some things for you to pay attention to when we actually get to the example, which is what I think will solidify hopefully everything. So without further ado then, and I'm hoping that my Ranger will stay logged in here, because I've got my file set up, and if it kicks me out, that means I'm going to have to go back in there and enable everything. So let me go ahead then and start the sharing. All right, so I'm going to jump into the slides. I started with the OO concept slides. I'm going to sort of dispense with that and ask you to read that on your own, and jump into more of the CS2 slides. Can everyone see that okay?
Yes.
We can.
All right.
I can.
So yeah, and so we've already talked about the differences between procedural and procedural and object-oriented programming, right? And as I mentioned earlier, from now on, you will write OO code, right? For the last seven projects, you'll write OO code, and hopefully that will help you feel more confident about your abilities, right? So we've talked about the differences. We talked about this last time, and I don't want to belabor this, but it, basically we're talking about taking things that are unrelated and making those things, the things being data and functions, related in some way, so that we can encapsulate it, and so we can get so that we can manage things a little bit better. Okay. The primary thing is when things are unrelated, the data is here, the functions are here, there's no tie. Okay. And we want to be able to tie those things so that we can sidestep some of the errors that come about, so that we can understand and maintain the code a little bit simpler. And I talked about classes and objects. Classes are sort of the template. If you think about this as a, for instance, as a little cookie cutter thing, right? That would be the class, and the individual cookies that you make from the star that you put into the dough. Well, that's the object. So each one of those cookies that I make with the star shape cutter there, that is an instance of the class, also known as an object, whereas the class just gives the thing shape. Okay, so a class looks like a blueprint in essence. And if I instantiate individual houses from a blueprint, I can print them different. I mean, I can paint them differently. I may be able to put a different door in based on what my class, my blueprint allows. I can change certain things and still be an object of the class. Okay, but if I decide to add something, that might throw me outside of the class, and so that's sort of a good analogy. Now the attributes are usually the members of the class. There are data members, and then there are function members, and so I'm thinking most of this is a review for most of y'all from CS2. Am I right?
Yes.
Yeah.
Okay. Which is why I'm kind of zipping through this here. All right, but the benefit that we get is this data hiding or encapsulation. We get this encapsulation of functions and the data that those functions operate in, and we're also able to hide, as I mentioned last time. When we have an abstract data type, all we are concerned about are the behaviors that are supposed to be provided by that data type. How that is implemented is hidden behind the actual code. Okay, so it's not evident through the public interface, which is how we access a class. It's not evident how those things are implemented. Okay, so let's see. And so we'll look at the public interface. The public interface is sort of the face that you put out there for everyone to use your class. Okay, usually that consists of the functions and data items that others can access, right? And I will make a big deal of when you're inside the class, because a lot of newcomers to OO don't understand when to use getters and setters, for instance. When you're inside the class, you do not need a getter and setter, and I'll highlight that at the appropriate time. Okay. Everything seems fuzzy and everything seems like, oh yeah, I need a getter for that, but you're inside the class, and so you don't if you're part of the class, you're already there. You don't need you don't need permission to access the elements of the class. Does that make sense?
Yes.
Okay. Yeah, so, right, so here's a class, right? Here is the syntax for the class. And I'm going to start talking specific things here that you should pay attention to. The entire class basically is defined, the declaration for the entire class is within this opening brace, right? And this closing brace with a semicolon afterward, okay? That is actually the class's entire declaration, okay? And anything that's outside of the class, if it's part of the class, it needs to be explicitly linked to the class, okay? I'll give you examples of that. But the class is this thing. The implementation may be elsewhere, but the class is this box. Okay, making a big deal out of that because it's a big deal to understand that. All right, so here is a class. The rectangle class has, you notice it's got a private section, it's got a public section. Okay, so this is the entire class, and there are a bunch of functions here, and you don't see any body for these functions. That's because the implementation for the class is not shown here. But this is how the class is defined. So we've got two doubles, a width and a length. These are private. They cannot be touched by any piece of code that is outside of the class, right? And then we have these individual functions. These are setters and getters, or mutators and accessors is the more formal name. A mutator allows you to change the code, okay? And an accessor allows you to simply access pieces of information. If you would, please double check, make sure you're muted. I'm getting a little bit of sound from something, so thank you. So let's see. So any questions on the fact that we're just telling the world about our functions here? Any questions on that? Okay, you notice that, and I will often write things this way. You notice that it lists a double for the set width function. That's the parameter type. You notice that there's no parameter name. Okay, that is pretty standard in the header file. Okay, so you just list the different parameter types, and when you implement these functions, that's when you give these things names. Questions? Okay, now access control specifiers are basically public and private, and then we will look at the protected class, the protected access specifier down the road. Okay, public elements of the class, whether they are functions or data items, are accessible by components outside of the class. Private data members and function members are only accessible by functions that are members of the class itself. Okay, which the flip side to that is, if you're a member of the class, you have access to everything. It's like somebody gave you the keys to the vault, right? You have access to everything. You don't need getters and setters if you're a member of the class. Questions on that? Okay. So we see the private members. There are two data members. Okay, they're both doubles. And we see the public members. This is usually the way things are, although it is possible to have both public data items and private function members, okay? So that is a possibility, but most of the time the data is private and at least some number of functions are public. The private and public sections, and when we look at protected, also the protected sections, can be listed in any order, and furthermore, they can be duplicated. In other words, you're going to have to kind of check in with who you're writing the code for and the standard that they use. Some places will say, here are the private functions, here are the public functions, here are the private data members, and here are the public data members, okay? So that means that both private and public show up twice, once tied to function members and once tied to data members, okay? And also for the for public. Okay, so that's what we mean by they can appear multiple times in the class. They don't have to be in any specific order. But if you do not specify an access control modifier, it does default to private. Okay, that's the difference between a class and a struct. A struct defaults to public, a class defaults to private. Questions so far?
Yeah, can there be structs in classes?
Yes. You can have classes within classes, and you can, so a class can have as a data member an object of another class, for instance.
Could you explain the multiple private public again?
Yeah, let me see if I can. Okay, so here it is, right? I can do this, public, blah, blah, and list my public data members. And then I can do private and list my private data. How laggy is this today?
It's working just fine.
Okay,
Yeah.
and then I can list public again. That's what I mean, and put my public functions here. This is not done often. And then private again, and list my private functions.
So is this more for a organization?
Yeah,
Reason?
it's kind of it's a coding standard that your company may adopt, right? They may decide they want it this way. All right, does that answer the question?
Yeah, I just was, you said the last part. I just didn't understand why someone would ever need to use that.
Do
That's
that,
what
yeah. Yeah, it's if you want to separate the data rather than separating it at the public private level, separate the data from the functions, and each one of those have a private and a public section.
And that's just seems to be a matter of preference for the company.
It's a style. Yeah, it's a style, and the thing is that the language definition says you can do this. Whether you do it is sort of up to you. I will ask that you only have one private and one public section. It just makes it easier to check, but it's not something that I enforce, right? It is legal. All right, you notice that some of these functions had the word const after them, and you notice that they're all getter functions, okay? Getter functions add this const keyword, which is optional, but it actually protects you. It keeps you from changing any data items, okay? It sort of enforces the fact that if somebody is asking for data, you should not be changing data. Okay, you should not be manipulating any of the data members in the class. By putting this const keyword here, that enforces that particular thing, so that if you have const inside the get with function, you try to change something within the class, it will not allow you to do that. Okay, so it's an added level of protection that says this is a getter, I should not be changing anything. All right. I will make a big deal out of the scope resolution operator, because the scope resolution operator is one of those things that is kind of difficult to understand just at a glance. But once you understand it, it's kind of locked in, right? The scope resolution operator is only used when you are outside of the class braces. That is specifically why I highlighted that box and I said this is the class. Okay, so if I place the implementation outside of the class declaration, right, the implementation is the definition, then I must use the scope resolution operator to tie it back to that class. C++ does not do it based on file name. It's not, oh, I've got ship.h here and I've got ship.cpp here, so it's going to marry these two things, right? It does not do that. Okay. In C++, if the implementation, i.e. the definition of a function, is outside of the class braces where it says class, class name, open brace, close brace, semicolon, if it is outside of there, you must use the scope resolution operator to tie that function definition back to the class. Questions on that? And that gives rise to another issue. You cannot redefine something that's already defined within the braces. Okay, that's called a redefinition, and you will get an error if you attempt to do that. Questions on that?
If you're tying your class into like a different namespace than global or standard, do you just kind of like chain namespace into class into the function that you're doing?
Give me an example of what you're talking about.
So like usually a lot of like cout stuff is in the standard namespace. If it's not in the standard namespace, we're usually operating the global namespace. But like if we're setting our own namespace, is that part of whenever you're defining a class function, whenever you're going to have that class in that namespace?
I have to think about this. I think you have to take an additional step to create your own namespace, if that's what you're getting at.
Yeah.
And I don't recall how to do that right off the top of my head, but I'll try to get you that. Don't let me forget. Let me write that down. Okay. So other questions? Okay, so then this here, this box right here, number one, it's not required if I'm within the class brace. Class C name, right? Class name, right? Open, close, and semicolon. You never have the scope resolution operator in here because there's nothing to resolve. You're in the class, right? You're inside the class and there's nothing to resolve. This only comes into play if you're in a different file or if you're outside of the class brace but in the same file, okay? And if you omit this, and this is supposed to be tied to this class, it will look for a function with this name that is outside of the class, okay? And more than likely, it won't find one and it will crash, or it will fail to compile. Questions on that?
So whenever you instantiate a class in your code and you rename it to whatever you want, can you use that name with that to access
Well,
the
you're
class?
you're instantiating an object of the class, right? You're instantiating an object of the class. When I say, ship, my ship, right? That's instantiating an object of the ship class.
Mhm.
Is that what you're asking?
Yeah, but I was asking, like, can you use the alias, the my ship, and then the operator set with?
Yeah, no, you don't want to do that because it's done at the class level, not the object level.
Okay.
The object, when it comes into existence, it's going to have access to all of the stuff that belongs to the ship class, which means the ship class better be complete, right? Everything that's defined, that's declared in here has to have a body somewhere, either inside those braces or in a different file tied in with the scope resolution operator. But that's a class issue. It's not a object issue.
Okay.
Okay, so you notice that this function then, it still has a type just like any other function. Think of this now as the function name. Function name, right? I mean, the function name is really this, but I'm having to tie it back to the rectangle class. All right. And again, C++ does not do that for you automatically. It does not do it by you including the .h file. It does not do it by you having the same name for the .h file and the .cpp file. All right, so a mutator then is a setter, okay? An accessor is a getter, right? So this is the setter function. It's usually going to be set something or other, and this is a getter. And so this just gets a value. Most of the time you want this const keyword next to it. This actually sets a value for a specific private data member that you don't have access to outside of the class. All right, so here is an instance of the class. Remember, a class is a type, okay? Just like int and just like double and just like string. So a class, once you define it, it is a type and you just use it like you would, right? If I was declaring I as an int, I would say int I semicolon. Well, I'm declaring a rectangle object here called R. And so I just prefix it with the rectangle class. And then I can access the individual members with the dot operator. Okay, so r dot set width sets the width of rectangle R to 5.2, and if I see out that using get width, because I can't touch it directly, then I should get 5.2 back. And obviously if you attempt to access something that's private, it will tell you you can't, and it won't compile. Questions? Okay, I can only see about 6 of you, so I'm assuming everyone else is engaged and paying attention, right? All right, so here we go. Remember what I said, this is the class right here. That means that even though the class body is in the same file, I have to use the scope resolution operator, right? The set width function, which is this guy, is defined down here. But because it's outside of this closing brace, it has to have the scope resolution operator. If it does not, it is defining a function called set width that has nothing to do with rectangle class. Okay, so whenever the implementation is outside of this opening brace and this closing brace, you must use a scope resolution operator, and that's what this is showing you. So you notice we've got two variables, width and length, which are both doubles. We've got a function called set width, which sets the width variable, and we see that here, right? You notice that width, it's this guy, right? Gets set to W, which is the parameter that came in. Here's set length. Notice again, we're tying it to the class by using the scope resolution operator. We pass in len, and it sets the length data member to the len parameter, okay? And then get width, in this case, get width is a getter, so it does not change anything. It just returns the value of the width data member. Get length does the same with the length data member. And then finally, get area returns the width times the length, okay? And then this is how we use the function. So this is what we would call the driver function that's going to use the members of the class. So we define a rectangle called box, and we define two local variables to main called rect width and rect length. And then we get these from the keyboard. So you notice it's got a CN statement here to get the rectangle width. What is the length? It gets the rectangle length. And then it sets box, which is a rectangle object and has a set width and a set length function members. It sets those values using the mutator functions, using the setters. You notice that in main, I am not using the scope resolution operator. Okay, this is important because oftentimes there's an inclination to do that when stuff is not working. We'll try that, right? You never use the scope resolution operator for something that's totally outside of the class. Okay. Questions on this? This is a very simple class. Let's look at the end of it. The end of it is it's just displaying the width, the length. So it's using the getter functions and the area. Okay. And it looks like this. This is the program running.
I have a question. So
Go ahead.
if in the declaration, like how it said double get area, and then later on when you defined it, you said it shows double rectangle get area. What if you changed it to like void rectangle get area? Would that even compile, or would it recognize it?
It would not recognize it. And when you provide the body for it, it will say, I don't have a function that matches this signature with the void type.
Got it.
Okay.
Thank you.
My question is, can you not just declare like a function inside of a class? Like, do you have to use the scope operator outside of the class? You can't just like in Java where you just make a function inside a class.
Yeah. If I could take these statements here, and just put them inside of the class. In other words,
yeah,
I can take this minus the scope resolution operator, cut and paste lines 41 through 44 and paste it inside the class braces.
Yeah. Would that be preferred? That's just usually how I do it.
It is not in C++. The notion in C++, the notion of having the implementation separate from the declaration is actually it's very C++-ish.
Okay.
Which is why we have these header files, and we include header files and the things of that nature.
Okay, thank you.
And that's how, that's how you'll do all everything you do here. You'll have a .h file and a .cpp file for every class that you write in this course.
So are we not going to do inline for getters and setters then?
You can do inline, and I've got some stuff on inline here, and I actually I ask you to do some of that in Proj 2. So you will do that, and that's okay. But if anything is not in line, it has to be implemented, and if it's not in line, you have to implement it in the .cpp. At the end of the day, the class has to be completely defined. Okay, so everything that the class has declared has to be defined somewhere. It doesn't have to be in the same within those closing and opening braces. It doesn't even have to be in the same file, but it has to be somewhere that is brought into the final executable. Questions? All right. So avoiding stale data. This is like the area variable. This is kind of a just-in-time thing, right? If somebody asks for area, rather than every time you change length and you change width, you have to remember to change the area of the triangle. Just access it at the time that you need it. That's basically what this is saying here. Calculate it at that very point, rather than trying to sort of keep it running as things come in. You could manage it for a simple class like this, but it gets much harder otherwise, right? So basically, if somebody's asking you for the length, don't try to set that every time you set the width or the length. Somebody's asking you for the area, don't try to set it, every time you change the width and length. Just at the time somebody asks for the area, multiply the two and return that. So to avoid stale data, it's best to calculate, the data member when you need it.
So in situations like this, it'd be best just to not even save area at all. Just have it.
That's right.
Okay.
Yeah, and so you notice we don't have an area. Parameter here. We're just returning length times width when that function runs.
Gotcha.
Okay, and you will have to do this for Proj 2. Okay, so I'm going to ask you to declare an array of objects. Okay, an array of pointer objects. Right? It's a lot less ugly than you would think. Right? Here's an array of rectangle objects. Rectangle. Right? Objects. Rect. ARR. 5 rectangles. Boom. That's it. Right? So it's not difficult, except you have to be aware of when you're using pointers and when you're using the object. Okay. And that sometimes is problematic. I know somebody talked about Java here. I think Java uses the new keyword differently than C++. Obviously I'm not a Java guy, but I believe that's the case. And so people that come over from there, sort of when they want a new object, they just say, hey, give me a new one of these. Well, new in C++ is dynamically allocated. So it returns the address of a new object, not a new object itself. Okay. So any questions about this, right? So you have to remember, when I declare a pointer, all I have is the pointer. I do not have an object, right? I don't have an object. So all I have is a pointer at this point, which means that for me to get something, I either have to have an existing object whose address I take, or I have to dynamically allocate an object, which is what happens 90% of the time. You hardly ever do this. Because why? I've already got this thing and it's called other rectangle, right? Why do I want to do this? Well, there may be a special case when I want to do it, but it's never just to use our pointer, right? That doesn't make any sense because I already have a name for this object. It's called other rectangle. Questions?
Is that an array of classes, like of each?
This is an array of objects of the class rectangle.
Cool.
Okay, each bracket I is a rectangle object, okay, which means that it's a class, so you get all the functions and all the data members that come with it. All right,
Okay.
go ahead.
What would be the advantage specifically in an array of objects of using an array of object pointers instead of just an array of objects?
Nearly always space.
Okay.
Right, it's nearly always space. If I can pass something smaller rather than pass something huge, Yeah, I'll choose to do that, right?
Okay.
All right. This is the equivalent of the dot operator when you are using pointers. Okay, this is called the arrow operator. It's called the pointer operator. I hate the term pointer operator. It's the arrow operator. Okay, that is the equivalent. You notice that we're calling the set length function, which is part of the class, right? The rectangle class. But we're not using dot here. We cannot use dot because our pointer is a pointer. It is not an object. Questions on that? Right? So if you want to talk about the thing at element 2 here, you would say rect ARR space 2, and then you would call some function out of rect ARR space 2, right? That's what you're going to want to do for proj 2. Questions on that?
So the arrow operator is basically like dereferencing it, right?
That's right. You can think of it that way. Absolutely.
Okay.
Okay. Right. But the dot will not work here. Questions? It is the equivalent of a dot if the object that you're dealing with is a pointer to the object and not an object itself. Right. This is an int. This is an int pointer, right? And those two things are different. Same thing down here, right? This rectangle R, this is an object. This is a pointer to a rectangle object. Okay, this is a rectangle object. Let me be more clear. Right? Questions?
So just out of curiosity, could you dereference a pointer and then
You
do
can.
the operator?
Yeah, I could dereference this guy. I can do this. Right? Our pointer now, that's the object, so I can use dot notation.
Okay.
Okay. Good question. All right. Other questions on this?
So what you just said, dereferencing our pointer allows you to use the dot operator?
That's right. Because when I dereference our pointer, I'm now talking about the object, right? Dereferenced pointer is the object. And the object itself, if I want to use a function off the object, uses dot notation.
Okay.
Okay. I will say though, standard for when you're using pointers, it's nearly always this way. It is seldom dereference and use dot. It's nearly always this way. All right. So we can use a pointer to dynamically allocate an object. Okay. You are going to have to do this for proj 2. Okay. No big deal, right? Remember that this is your pointer. This is your pointer right here. So if I have a pointer and I want an object, what do? I put the pointer without any asterisk or anything on the left-hand side of the assignment operator, i.e. the equal sign. Then I invoke the new function and I put the correct type, right? The new state, I issue the new statement and the type, right? The same thing here. If I want a rectangle, here's a rectangle pointer called rect pointer. It points to null pointer initially. This is how I allocate a new rectangle. Okay, well, if in rect array, then from the previous one, rect ARR 1 equals new rectangle, right? Questions on that? Right? Remember, the new operator is it will dynamically allocate, so it always returns a pointer. It always returns an address. The new operator always, forever, always returns an address, right? Anytime you you write the new operator, make sure that you want an address. Make sure that the thing that you're trying to put that result in is a pointer. Okay. Questions on that?
I do have a question. So, would it be rect at 1 and rect AR1 instead of 0? Like why?
Well, I'm just giving you an example. This could be
Okay.
1, it could be 0, it could be 15, right? As long as you have an array that's that large, right?
Okay.
I'm just, or better yet, we could make this rect J and put this inside of a for loop and have it, right? With one statement, I declare n, n individual rectangles, right? I can put it inside a loop and just use that as the index, right? Questions? Right, so go ahead.
So this is a little bit different topic, but what's the difference between null pointer and capital null?
Capital null is the old way to do it. Null pointer is sort of the new way. When you're dealing with null used to be, they're both 0, okay, to be frank, but null used to be used for everything. Like C was crazy untyped. It's typed, but you could do anything you wanted. Basically, you could convert this type to that type without casting and things like that. And everything was null. Everything that was like 0 or zeroed out was null. But here we're trying to tie the fact that it's a pointer to the fact that this is a pointer. Okay.
So functionally, is there any difference?
There isn't.
Okay.
Okay. You get certain, the compiler will match the size of these, but really when you say rect pointer equals null, if this is an 8-bit guy, it will put that 0 in 8 bits. And if this is a 4-bit guy, it'll put that 0 in 4 bits. So it really doesn't matter, right? But you should use this, right? This is, so you asked functionally, it doesn't matter, but professional software people are going to want you to do this, right? Because it's a pointer type. Okay. Other questions?
In terms of space, a rectangle pointer isn't any larger than like an int pointer, right? Because it's just storing an address.
It should not be. That's correct. Usually 8 bytes. Nowadays with these large memory models we have, 8 bytes is most pointers are 8 bytes. It depends though, right? Because if you've got a lot of memory, remember the number of bits that you have will actually restrict your ability to access memory. So, all right. Any other questions? Okay. So you notice that then once we instantiate a new rectangle, we can call the member functions using the arrow operator. And then we just have to remember to delete the rect pointer, right? Delete rect pointer and set rect pointer to null. And that just ensures that we don't have a dangling reference, right? Because when we delete it, all it does is it says to the system, you can have this memory back, but it doesn't make you forget that you had access to that memory location. And technically, if you could go back and change it, right? But you're not guaranteed to be able to keep it. Questions?
In this case, for the rect AR for the array, would we have to do like the bracket way of doing it, or the array way of doing it?
Right. So this is that what you're talking about? Like this?
Yeah.
Right. So this is a rectangle. This is an array, which means that the thing that I want to access is its index is specified in here.
Yeah, for our case for proxy, when we go to delete that array pointer, don't we have to put the?
This is your pointer right here. So you can just delete. What you can't do, you can't delete rect array.
Okay.
Okay. Rect array is a static array that holds pointers. Static variables cannot be deleted. Only dynamically allocated variables can be deleted. Okay. So you cannot delete this whole thing. You have to loop through and delete the bracket thing.
Okay.
Does that make sense?
Yeah.
Because you have to loop through to create the individual bracket things. You have to loop through to delete the individual bracket things, right? Does everyone follow that?
Yes.
All right. Let's see. Where are we with time? Because I don't want to.
About 35 minutes.
Yeah. So, why private members? We're protecting data, right? We don't want everybody and anybody to touch our data and change it without us knowing about it, right? Yeah, it allows us to keep track of bookkeeping and things of that nature, right? But this is key, right? I get code, and this is not a slam, right? I get code oftentimes where you're inside the function and you're using a getter, right? You're inside the class and you're using a getter. Don't do that. What do I mean by you're inside the class? If a function gets called that's part of the class, you're inside the class. You don't need to do a getter to see your bro width and length, right? They're right there for you, right? Okay, so if you're inside any of these functions that are part of the class, any of the functions that are part of the class, you have, and by that I mean like here, even if they're a bunch of private functions, you have access to all of these things. You don't have to use a setter to set these things. You don't have to use a getter to get these things. You're in the class, and so you know you have access to everything. Questions?
So for a rectangle class, if we were getting the area, we're declaring the function for area outside the class, right? But so long as we do the scope resolution operator, we don't have to get the length and width within the declaration of area, right?
So there's a slight bit of mixing a couple of things here, right? So if I say rectangle scope resolution get area,
right,
like this, this guy is let's say it returns an int, right? This guy is a member of the class, whether he's sitting in the same file or not.
Right.
And as a result, I don't have to say W equals get width. I don't. That's what I was trying to. That's the point I was trying to make.
Okay.
I don't have to do that. I just go with, right?
Yeah. That's exactly what I wanted to confirm there. Yeah.
Okay. Times length. Yeah.
Okay.
All right. Return this. Questions? All right. This is good. We're about on time, right? Now we're going to talk about separating the specification or the interface or the header file from the implementation. Okay, that's in essence every piece of software you write from now on. You will be required to separate the specification or interface from the implementation. Okay, so you're going to place the class declaration in the .h file. Okay, and that's going to be called the class specification or the class interface. I use interface more often than specification. Okay, and so you'll name it this. I will ask that you name it with lowercase. Okay, lowercase .h file. Okay, so in my world you would do this, right? Rectangle with lowercase. Then you're going to place the member function definitions that are not in line, okay, you're going to put those in the class.cpp file. The class.cpp file must include the header file, okay? It must include the specification or interface or header file. Questions on that? And then the other thing that will include the header file is the driver. The driver program is like main, or whatever piece of code is using your class, okay? So programs that use the class, i.e. main, they must also include the class. Questions? Now, some of you will do this because you can't get it to work, so I'm gonna write it really big here. Never include the .cpp file. Never, right? Sometimes that's the only way I could get it to work. Well, you're doing something wrong, right? So come see me, come talk to me. You never include the .cpp file. Never, ever, ever. Okay. Questions on that?
Yes. The obvious point is why.
Why? It's just outside the specs of the language. And if you have a .h, you're going to end up redefining some things. You just, you define it once and you pull from the definition, and you have everyone else that wants to use the class pull from the definition, i.e. the interface, but you never do this. It's just bad practice. You're doing something wrong if you have to do that to get it to compile. All right. Probably not a very satisfying answer. It's just one of those things you don't do. Like
no, it really isn't. It's like, don't do it because I said so.
Yeah. that works too, right? All right, let's talk about. Go ahead.
Back with what you said about making sure the .h file name is lowercase. What if it's made up of multiple words? Would we only lowercase the first word or lowercase everything?
Probably lowercase everything. I will give you the file names that you must use. Okay. And it will say the header file must be called this, right? And it's all lowercase. Now the actual class name will be in uppercase nearly all the time. Okay.
Right.
So the class name, like the keyword class followed by that name will be in uppercase. But I ask that you make these lowercase, and because we're in a Unix system when we submit, we'll want to make sure we honor that.
Okay, thank you.
All right, so inline member functions are functions that are defined inside the class's declaration, i.e. the header file, i.e. the interface file, or the specification file, okay? Questions on that, right? So an inline function looks like this. Whenever I say inline, I never mean use the inline keyword, right? This is what I'm talking about right here, but it's in the .h file. Yeah. What you're saying is you're providing the body inside the .h file, which normally doesn't happen, okay? Louis?
Yeah, so I was reading the specs and I was wondering about that, whether you meant to use inline or not. I'm unclear on what the difference is between using the actual inline specifier versus just doing the function inline or the definition.
It really, in both cases, it's a request, right? In the case of explicitly using inline, you're asking the compiler, but the compiler is ultimately going to make its own decision based on the optimization level that you have selected or the native optimization level of the compiler. You're asking it to, in essence, copy that code everywhere where that function is called. Okay. And if the compiler deems that that's too ugly, it won't do it. It won't honor your request, right? Okay. By putting it inside the header file, it automatically, if you provide the body, this is what makes it an inline function, is that I did not just do this. This is what we had previously. Now I got rid of this and I provided the entire body for this function. And I did that in the .h file, or really more specifically, I did it within the class open and close brace. In this case, it will set that piece of code everywhere where that function is called. And that keeps, what that keeps it from doing is the function overhead, right? Functions are expensive computationally. When you call a function, it has to store a bunch of stuff. It's on the stack, right? It's storing a bunch of stuff, and then it's allocating a stack frame, copying some stuff over, and then providing you what you need. And that's computationally expensive. So for something like this, where this is the whole body, just go ahead and copy this everywhere. Okay.
So inline is telling the compiler to do that, but not including the actual definition there? It's like an alternative, or
well, you're requesting that the function that follows the inline keyword be placed inline in the generated executable file.
Yeah. Okay. Thank you.
Okay, you're welcome. Other questions? Okay, so this is what we mean by inline data members, and this is probably a good point for me to sort of break off and do the other thing. When I ask you to do inline stuff in Proj 2, I'm just saying provide the body for the function inside of the class open and close brace. Okay, there's no need for the explicit inline keyword. So these three functions are all inline. They're all consts. They're just returning values. And that's usually where you'll see inline. It's kind of const stuff, or if I'm just setting one value, I may provide some setters that are inline as well. Okay, so here it is, the trade-off. Basically, it's going to store the return address, you know, if you do a regular function. Otherwise, it's basically going to copy that block of code and move it over. Now, there's some other stuff that goes on in the compiler to make that happen. But in essence, that's what it does. It takes away the overhead of a function call. All right. I'll talk about constructors in the context of the example I want to give you. So the example I want to go over is, I want to make sure my, all right, it's still alive. Good. The example I want to go over is closely related to Proj 2. Okay, so in Proj 2, we're going to have a class called a gas pump, and you're going to instantiate three-pointer. You're going to have an array of 3 pointers to gas pumps. One takes a medium grade, the other one gives high grade, the other one gives low grade or regular grade or whatever, and so we're going to run 50 cars, or we're going to run some number of cars through those gas pumps, and we're going to ask you to collect some information. Every car is going to ask for a specific purchase of gas. I want $25 worth of gas. And every gas pump has a per gallon cost, so you're going to have to do a little bit of math there. And then every pump will maintain a count of how much gas it's dispensed and how much money it has collected, right? Now, I'm not going to give you the entire, you know, solution here, but what I want to do is give you the outline of what it takes to make something like this run. And hopefully it'll be easier when you try to tackle it on your own. So I'm going to share this guy, and then I'll go here. All right. So what I've got here is a snack. Basically, think about it as 3 snack stores, and a bunch of people are going to go through these. A bunch of people are going to come through the snack store, and they're going to try to figure out. They're going to try to figure out which snack they want and how many snacks of that type they want, right? And so here are the possible snacks are ice creams, chocolates, and donuts, okay? And you can buy from 1 to, I think, 5 of these things, okay? So I can buy 3 ice creams or 1 chocolate, or, you know, 2 donuts or whatever, okay? This file is set up a lot like Proj 2. The first number is the random number seed, because we're going to be randomizing which store you go to, just like we will randomize what gas pump you go to. And the second one is the number of people that are going to purchase snacks from our 3 stores. Does that make sense?
Yes.
In each of our stores, we have an ice cream shack, a chocolate shack, and a donut shack. Okay, so we've got 3 stores, just like the parallel, high grade, medium grade, low grade. Okay. Let me show you a .h file. Okay. This is a .h file. I want to talk about everything that's here so that you understand everything that's here, and so you can replicate it yourself. You can use Pragma once here, but I will ask that you use, eventually you can use Pragma once. Pragma once, for those that are not familiar with it, ensures that when you include a .h file, it is only included once. Because if you include a .h file without include guards, that's what these are called, and you include it more than once, and every application that you use in this class will include it more than once, because main will include it and the .cpp for the class will also include it. So it'll include everything at least twice. If you don't have include guards, or you don't have Pragma once, when I free you up to use that, it will run through this twice and it will say, I've got a definition for class snack. Oh, and I've got another definition for class snack, and it will say that's a redefinition, and it won't compile. Okay. So the way to read this is that if the symbol snack ._h, and that's how I'll ask you to name all of them, name them by the class name and then _h. If that symbol has not been defined, which it will not be when we first start this program up, then define the symbol, do all this stuff, and hit the end if, right? So this is basically, it's an if not defined. That's what if end def stands for. So if the symbol stack _h is not defined, then define that symbol. You notice we're not giving it a value. We're just saying this symbol is now defined. And then do the body of your function. I mean, the body of your class here with all your includes, etc. And then you will hit this end if. The next time this file is included in that same compilation, okay, this is a per compilation thing, it's going to come across this and it's going to say, if not defined snack H, but it's going to say, oh no, somebody's already defined snack H from the first time I went through this, right? So in the event of the CPP file, it hits this, it defines snack _h, it does all this stuff, comes back. When main tries to include snack.h, you notice we're talking about the header file, it's going to come in here and it's going to check snack.h, and it's going to find that it's already been defined, and it will skip directly to the end if. Does that make sense?
Yes.
Okay. I need more. Does that sort of make sense to everyone? Not sort of, but does it make sense?
Yes,
Okay.
sir.
All right, good. Okay.
Yeah.
So we're going to provide these include guards in all the .h files, and that's the only place they go, right? It's the .h that gets included. Since we never include CPP files, we have to only put these in .h files. Now, we're defining our class snack, and you notice it's got two private data members. It's got a snack name, in essence, a snack type, right? Which is one of these. And I think I changed these to plurals at some point. And then it has the number sold. That's in essence what we're tracking here. That's what this class, this snack store, is going to be tracking. Okay. Now the snack store only has one of these snacks. We'll declare an array later on that ensures that we have enough stores with all the different types of snacks. But it's important to understand that you will get one snack type for this store. So that object is only a chocolate store, or it's only a donut store. Okay. Questions on that? Okay. So both of these guys are private, meaning they cannot be accessed from outside the function. Now here's what we have as our public functions. We have the snack constructor. Okay. And the constructor, this This constructor is going to do very little because I want to basically start you off at ground zero, right? You notice it takes no arguments. Okay, it doesn't have a parameter, so it takes no arguments, and it turns out it's just going to initialize this number sold to 0. Okay, which is the way we used to have to do it before C++11, but C++11 now lets you say int number sold equals 0. But before C++11, you couldn't do that, so you had to do it inside the constructor, and I want you to see that. Questions on that so far?
If you didn't have that constructor in your public, would it give a default constructor at all, or would it just?
It would, but the default constructor does nothing, right? It can't read your mind, so it does nothing.
Got it.
Okay. Furthermore, if you define a constructor with any number of parameters and you fail to define the default constructor is gone. Okay,
Understood.
it is
Thank
gone.
you.
Okay. All right. And then we have a function called get snack type that returns a string, and that string, as you can imagine, is the snack type, either donuts or whatever, donuts, ice creams, whatever. Then we have a get number sold. We're going to use this at the end to total up, to look at the totals for each one of these things, and each one of these stores. And then we have, so you notice that both of these are inline defined, right? These functions are inline. Their bodies have already been defined, which means they don't show up in the .cpp file. Okay, that's a redefinition. If I give this thing a body in the .cpp file, I will get a redefinition error. You can only define something once. Now, these two functions are not implemented. The set snack type, I could have implemented it here, but I wanted to, I didn't want by snack to be all by itself. So, I created this so that we implement two functions, and two of them are already implemented here. Okay. Questions on this class?
So unrelated to the actual class itself, but so whenever you do the standard and then the string, is that the same as the scope resolution operator?
It is, and that's because I don't include namespace standard on most of my code.
Okay, I just didn't know if it was related or like it served as two separate things.
No, it's the scope resolution operator. It's in essence taking it from the standard namespace. Okay. Questions? Other questions?
Yeah, I got one just about the syntax on the define at the top.
Yep.
It's always all uppercase under, I mean, is that how you do it?
It's that is my choice. Okay. Just as long as these two are the same. Now I will ask you to use uppercase with an _H in this class.
Okay. And then when you're in main or whatever, that's how you reference it?
No, when you're in main, you will include snack.h.
Okay, like you're doing with the IO stream there?
Yes.
Okay.
Yes.
Thank you.
Okay. So think of this as sort of the foundational, right? This is the class. I mean, this is the class's declaration. This is the foundational item. This is where we start, right? Somebody says do a class. I got to come in here and do a class keyword, class name, and start doing this stuff. And some of it I'll do inline, and some of it I defer to doing the .cpp. Okay. Questions? All right. So here we go. Let's go to the .cpp file. Well, in the .cpp, before I click there, what do you think we'll have in there based on what we've talked about so far?
Set snack type.
Oh,
Member functions defined.
all the implementation stuff.
Implementation stuff for what? For what exactly?
For the two
members functions.
These two members and this guy. Don't forget this guy, right? And the constructor. That guy's undefined right now. He's declared, but he's undefined. Okay. All right. What else?
It's including the header file.
The inclusion, right? Including, there's a line to include this. Okay. All right. Good. Here's snack CPP. It includes snack.h. It includes IO stream, which really it doesn't because it pulls it from there. But I tend to do IO stream and string. I put those in every class, right? And the system is smart enough to only include it once. So it's not, there's no nastiness going on here. Now you notice that for me to define the constructor, which has the same name as the class, I must prefix it with the scope resolution, the class name and the scope resolution operator. Why? Because I am outside of that open and closed brace for the class. Questions on that? All right, and we said we had 3 functions to implement, and lo and behold, that's exactly what we have here. You notice that we don't have anything that does anything here that's outside of the class, right? This is all class stuff. It will all be functions, and it will define the behavior of these various things, right? So all I want the system to do when I declare and I have these in an array, so I will make the point, I will connect, I'll circle back to make a point there. But all I want it to do is to initialize all my stores to 0 items sold, okay? And I'm going to set what those stores sell kind of later on, okay? So any questions on that?
Random question. You mentioned that set snack type could be inline.
The set snack type could have been inline if I just provided this body here inside curly braces like I did.
But not the constructor or by snack.
The constructor can be inline as well.
Oh, okay.
Yep. I mean, the constructor can be defined in the, you know, I hate to use that inline term because inline is a request, right? The compiler is going to decide whether it's really inline in the final code or not. But it can be done in the .h file if that's what you're asking. That's true. Okay.
Okay.
All right. So this guy just initializes number sold to 0. This guy sets the snack type to the parameter that came in, which I called S type here. Okay. And this guy allows you to buy some fixed quantity, right? Some integer value of snacks. And you notice that this is what's updating the number sold member variable. This guy, right? Number sold. Okay. Any questions on that?
Yeah, I have a question.
Yeah.
So in project 2, are we gonna get told when we do inline and when not to do it?
Yes. I tell you in project 2, implement these in line, and if it doesn't say to implement them in line, then you should implement them in the CPP.
Okay. Thanks.
All right. So we're back here, right? So again, we include snack.h. Why? Because this thing doesn't know anything about the class snack. Even though it has the same name is insufficient. I can rename this file to I don't care.cpp, and as long as I give it the scope resolution operator, it will still work, right? And if I don't put the scope resolution operator and I keep this snack.cpp, it will not work. All right, make sure you understand why that's the case. Any questions? Right, so what we've done now is we've declared a class, and now we've defined exactly how that class works. Now we're going to use the class, and this is where things become different, right? You may use it this way, you may use the class that way. We're going to use this by running a fixed number of people through the stores. We will randomly choose which of the 3 stores they go to, and we will randomly choose how many snacks they buy at that store. Okay. And then you notice that this guy, every object of snack type is keeping track of how many things they have sold. Okay. So when somebody says buy a snack, I want 3 snacks. I'm just going to bump up number sold by 3, right? Number sold started at 0 when I constructed the object. Questions? All right, we're almost there. All right, here's main. You notice that main has to include snack.h. You know, Sal Barbosa's, you know, way is to always include these two, so I included them. And here's the fstream object because I'm going to play around with opening a file. I declare an array of 3 snack objects, and I call them stores. Okay. Okay. This requires a default constructor. You cannot declare an array of objects without having a default constructor. This is important because if you write a 2-parameter constructor and you don't write the default constructor, it erases the existence of the one that the system provides you for free, and you cannot declare something like this. Now, the difference between this code and Proj 2 is that you're going to be dealing with pointers in Proj 2, and here we're dealing with actual objects, right? So I have to leave you some work to do, right? Here my int variables are the random seed. That's going to set the random number generator so that all of us get the same number, okay? That we're going to get the exact same result. The number of customers is going to be read from the file. The store index, that's which of these 3 stores I pick. So the valid indices are 0, 1, and 2. And the snack units that the customer wants to buy, the number of snack units, that goes in this variable. Here's a string that has the snack type. I'm going to read that from the file. That's going to be read from this file. Okay, nope, not that file, but this file right here. Okay, these are the different snack types. And then I open the file. I declare the file and open it. Make sure it's open. That's this if statement. And then I read the first 2 things, the random number seed and the number of customers. Random number seed is 500, number of customers is 25. Okay, and then I loop through and set each one of I read each of these. This is element 0, element 1, element 2 in the array. I read through all of those and I assign them the correct snack type. Okay, so I'm saying store 0, you are chocolates, or sorry, store 0, you are ice cream. Store 1, you are chocolates. Store 2, you are donuts. Okay. And so that's all this does. I read it from the file and I call the setter to set the object's snack type, right? So now we have 3 stores, all of which have their counters of numbers sold initialized to 0, and they all know what kind of snack type they have. We now seed the random number generator, and I'll talk about that probably next time. Seeding the random number seed generate the random number generator ensures that we get the same sequence of numbers, and then I loop through the number of customers. How did I get that? Well, that was the second line in my file, right? You notice that input file went into random seed first and then into num customers. Here's random seed. Here's random seeds is top one. Num customers is the second one. Okay. All right. And let's see. So so down here, we're going to pick the number of snack units by calling the random number generator and modding it by 5. The random number generator returns an int between 0 and rand max, right? The maximum number returns an int. If I take something and I mod it by 5, what do I get?
The remainder.
Right, which is between what and what?
0 and 4.
0 and 4, integer values, right? Since I don't want to stand in front of your store and buy nothing, I add 1, okay? So hopefully you can see that you will either buy 0, 1, 2, 3, 4, or 5 units of snacks, right?
Jim.
I do another random number draw and I mod by 3, giving me 0, 1, and 2. Those are my indices into my store. Okay, I only have 3 stores. The indices are 0, 1, and 2. So I'm modding this by 3, which ensures that I get 0, 1, and 2. Louis, you had a question.
Yeah. So in the project, there will be, in the input, there will be a random number seed. Do you just want us to handle it, like put it in the parentheses after rand?
Yes, after srand. That says seed the random number generator. That's what that means, right? And you notice I didn't have to include anything fancy. It comes as part of the system, okay?
So we will or won't have to rand mod in our.
You will be told exactly how to generate the random number. I will describe it to you. I'm not going to give you the exact formula. I'll describe it to you, but I think I describe it to you. Maybe I change that and give it to you, right? But just follow the specs. If you have questions, let me know. All right. So at this point, once I know, so this is, I'm looping through every customer. Once I know how many units that customer is going to buy and which store they're going to buy it from, then I go to that store, use that index, and call the buy snacks with that many units. And then I'm outputting here, hey, customer I, and since this is 0 base, I add 1. He bought X snack units from, of this type. Okay. That's it. That's this loop. At the end, these are the totals. I'm going to call the function get snack type for each of my 3 stores, and it's going to tell me how many were used. Question: how many were sold? Questions on that? I'm sorry, we're going over here. I'm hoping to get you out no more than 2 more minutes. Makefile. This is the same makefile that is on the course website. The only things I changed are these file names, .cpp only, and this executable name. I want to show you how a makefile works. So if I cat the makefile on the right, it looks exactly like this, right? This is a line that says what compiler we're going to use, because we can use CC or GCC. These are the compiler flags. These are the linker flags. We use none. These are the source files. That's only .cpp. This is the executable. This is how you convert the source files to object files. Okay. So that's just the rule. You don't have to worry about that. The only thing you have to do is change this line and change this line. That's it. Questions? All right. So I'm going to do a make clean to just make sure it removes any object files and it removes any core files if you crash your system. Okay. Make clean. And now I'm going to do make. Let me show you what files are here. They're all the files we just looked at. Here is snacks.txt, which is the file that's going to give me the input. Here's snack.h. Here's snack.cpp. Here's main.cpp. Here's the make file. I just type make. Type make. It makes the file. Now when I do an ls, you will see that I have this executable snack right here, which I did not have before. And I also have 2 object files, which I did not have before. Okay. To run this on Ranger, /snack. And we can go through and count these if you want. Ice creams, there are 4 plus 4, 8, right? 13, 16, 19, 21. Okay. And if you go through, you can see that all of these are correct, right? They're all captured down here in the totals. If you trace every one of these, you'll see that correctly maintain the number of things that we bought at each store. Okay. The only difference here between this and Proj 2 is the biggest difference is you'll be using an array of pointers, so you'll have to dynamically allocate, and then you'll have to follow different logic for the car, right? You'll have to come up with the amount of money that the customer wants to spend on the gas. This is not posted yet, but I'll post this, right? The constructor will have a few more parameters, etc. All right. So sorry for holding you late. But I'll take any questions. I'll stop the share, take any questions, and I'll open up the office hours link here in a second. All right, so any questions?
Have a nice weekend, Dr. Barbosa.
All right, thank you. You too. I'll stop the recording here. Any last minute